Yes, and like I said, there's some things that are more expensive. There's there's some examples here that could be implemented today, uh, hardware-wise, but the software remains proprietary. It's to a certain degree, it's owned by the student, my student PhD students who are building it. So there's some software that is public domain. There's a lot of augmented reality software that is public domain. Um, there's some software built on top of Flash, which people can use. And so some of these examples. Let me push to the first example, and this kind of gives you an idea if you want to come in on what I'd say the low end of it. It's still very effective. So if we look at the picture at the top here, now this particular configuration of this, although it's AR because it's combining the physical and the virtual, you're not viewing the physical object. You're viewing a representation up here in some sort of display. And so I would say this is probably the most low-end form of AR, but it is another form that will become popular. And this is the same technology that the Magic books use. And so on the bottom we can see some pictures of some of what a student would do to interact with some molecules. Sorry for the low resolution of these. These are the best. And so what ends up happening is that this cube here, you can attach a molecule to the cube, and then you have this marker down here. And then what you do when it comes in contact with that marker, you can then do some sort of experiment with this. And this one here shows how the molecule changes when hydrogen is attached to it. So now this technology here is all most of the actual tracking technology and the AR technology is all public domain. So you can build your own systems now, and so people are doing that at the moment. Okay, so this combines the kind of nice tangible aspect of this with the virtual aspect. You're not wearing any headsets or expensive projectors. You're using just traditional desktop computing with a webcam, and that's the only thing you're using. So this is another chemistry project that's this one was actually geared to university students. The previous one I think was more geared towards high school students. And once again, it's to get students to understand the interaction between the different molecules. I tried to put the names of the project and the author's name so you can at least chase them down in Google Scholar. And so once again, we have these boxes. These just make really cheap technology for tracking, and these are visualizations of what happens when you get attachments between two different atoms, and the students can then play with them, as it were. And that's what these things are trying to encourage people to do is, well, if I come close, what are the bonds that get made? How hard is it to break the bonds and things of this nature? So another way to look at this is Cyra's been looking at some training tools for medical staff. And so one of the things that they would like to do is get rid of cadavers for lots of reasons. And so they've been investigating the combination of this thing over here, which is, let me get a bit. This is what's known as a haptic device. So this adds the sense of touch to it. So there's this pencil-like object that the user holds, and when you push it up against the head, then you feel something solid, or if it's skin, it feels kind of squishy like it's skin. And so what this allows people to do is interrogate some anatomy, or in this particular case, brain anatomy, and the sense of touch and the visual sensations allow people to feel like they're actually interacting with something that's a bit more real. One of the things I like about the spatial augmented reality, it does have this passive haptic nature. You can physically touch things, and that's something that really I think needs to be included in any educational um, tutor or whatever system that you have, is the ability to touch and interact with it, whether it's a tangible prop or something. That I think that's the key to making this work. So Sire took this technology, and then this is a museum artifact. And so once again, down here you can just barely see it, but there's that little white card. They're using this tracking technology, and then you can then interact with the different objects inside there. So the physical nature of this is the fact that you can move this card around, and then there's a kind of a nice aspect with this haptic device. I'm not real familiar with this, but yes, in this particular case here, there's all these words that tumble out of here, and then you can select these words, and you can get more information about them. And so it's a way you can drill down and interact with the piece. The nice thing about this, as opposed to a traditional museum piece, is you just put out different cards in front of the same piece of technology, and then you can get different artifacts. So the ability to build complicated visualizations and interaction and museum exhibits is quite good. And then you can also, without having to physically rebuild things, physical walls and things, you can change your exhibits more quickly. So this is an exhibit. I haven't seen this exhibit. I've seen most of these other pieces of technology, and so the idea of this is that so you have your webcam here, and then you have these black and white markers again. People use this technology because this technology's been around for over 10 years now. It's tried and true. It's very cheap to use. Generally, what ends up happening is that the two major pieces of technology that make this fall over is the tracking. So what you want to do is you want to have a mapping between whatever physical object you have and whatever virtual object you have. So you need to track these. You need to track whatever interactions you're having and whatever display device you have. So what makes this such a great museum piece is that you don't touch the display. It's just a normal plasma or LCD display. The camera's hidden behind some piece of glass so people can't break it. And the only thing they touch is this Lazy Susan and these little markers which you can move around, which are just very cheap to reproduce. So this one's a little bit more ambitious. It's actually an older piece. But what ends up happening is with head-mounted displays, you're able to have this sort of fantastic appeal. So this cone here would appear between these two. These are two grad students, and so what happens is the scenario that this was working on is the idea that you'd have a teacher and a student, and you'd be able to walk around and view things from different angles. And in this particular case, they were looking at geometric shapes and conics. And so where in conics, it's part of it is the ability to slice existing cones and other shapes, and then whatever 2D shapes or 3D shapes come out of that. And so this allows you to do it in real time and visualize it and interact with 3D artifacts, which is currently the way you do it is you have a fixed shape that you then pull off and either Velcro together or whatever.